Hey, Mr. Snyder here today. We're going to be talking about algebraic expressions. So we're going to be looking at everything that goes into that, just some of the basics. So we're going to start with just a expression. We'll look at some of the vocab that's involved. Then we'll be talking a little bit about distributive property and how that works. And then just a review of simplifying or reducing like terms or combining like terms, okay? So let's get started. So just basic things that I would kind of understand would be this. If you have an expression, and an expression is a linking of what's called terms or just algebra pieces together without an equal sign, we call those expressions, not equations, okay? If there's an equal sign, then we call them equations, and if there's an inequality, we call them inequalities, okay? But if it's just the terms by themselves or just the algebra by itself, we call that an expression, okay? So let's say we have the expression 5x squared minus 3x plus 2, okay? This is an expression. It has three terms. A term is what I like to just call a chunk of algebra, okay, or a slice of algebra. So these are just the terms here. So 5x squared is a term, negative 3x is a term, and 2 is a term, okay? Within each of the terms, you have your variable, okay? So you have your variables. Then you also have what's called the coefficients, all right? And that's those guys right here, okay? All right, so you have your variables, you have your coefficients, and for the most part, that's the basics of the vocab that you're going to need to know. So let's get started. Let's look a little bit about this thing called the distributive property and how that helps us simplifying algebraic expressions. All right. So let's get started with a couple of those problems. All right. The first one that we're going to do is 3 times x plus 5. Okay. When you're in this situation, it's always good, especially when you're simplifying algebraic expressions, to get rid of parentheses. It's one of the first steps that you're always going to want. So if you see if you see a parenthesis, you're going to want to get rid of that. And the best way to get rid of that is to multiply the 3 into the parentheses, okay? And the way we do that is making sure that each of the terms inside of the parenthesis gets multiplied by the 3 on the outside of the parenthesis. Usually we draw like little lines to help us do that, okay? So 3 gets multiplied with x, 3 gets multiplied with 5, okay? So 3 times x. The way we show that is just by linking the two things together. That signifies a 3 times x. We don't do anything else from there because, again, we don't know what x is. It's an unknown. It's a variable, so we just attach them, and that's how we show that in math. Now, on the other hand, we can perform the next multiplication problem, 3 times 5, which is going to be 15, all right? To figure out what symbol goes in front of the 15, you just ask yourself, after doing the multiplication problem, what does that result in? Does it result in a positive number? Does it result in a negative? If it results in a negative, you leave a minus out front. If it results in a positive, you leave a plus out front, okay? Let's try one more real quick. This one involves one of my favorites. Let's put a little negative out front. So we got negative 2. X minus 7, okay? So let's distribute that in, okay? So same deal. We got negative 2 times x, and we got negative 2 times negative 7, okay? Negative 2 times x, you just link those two terms, or two numbers or variables together. Negative 2 times negative 7, this is where things get tricky. You just have to make sure that you remember that rule, that two negatives multiplied together gives you a positive. So let's go ahead and write that down. Alrighty, so negative 2x plus 14 is going to be our answer, okay? Let's just try one more real quick. The last one we're going to do involves a fraction, so let's see how that affects things. It shouldn't affect things much, but let's go ahead and try it anyway. So we got 8x plus 12, alrighty. So 3/4 times 8x, okay? We have to multiply that first. So let's just go ahead and write that out. Okay, so I'm going to do this a little bit longhand this time so that we can see all the steps. Plus, we got 3/4 times 12. Now we haven't really talked about what happens when I multiply a fraction by a whole number, but what I like to do is I like to actually turn those whole numbers into fractions. So if you ever have a whole number and you want to know how to turn it into a fraction, the answer is you just put a 1 below it, okay? It doesn't change it, but it does give you a fraction to play with, all right? So here, let's go ahead and try this out. So if I put a 1 underneath this and I put a 1 underneath that, now I just have fractions I can multiply. So I can multiply across the top, and then I can multiply across the bottom, okay? So 3 times 8 is going to give us 24 over 4 times 1, which is 4. The x, I like to just put it next to it because, again, that fraction will multiply next to the x. You don't have to worry about putting it next to the 24 down below. I like to just put it next to the fraction, okay? You don't have to do anything more fancy than that. Plus, we got 3 times 12 here, which is 36, over 4 times 1, which is 4, all right? Now, at this point, we can simplify these fractions by dividing. So 24 divided by 4, that's going to give us 6x. 6 will multiply by x. Again, the x just doesn't move. It's not affected. It just has to be attached to that number. And then 36 divided by 4, well, that's just going to give us 9. Okay, so the answer to that is 6x plus 9. All right? All right, once you go ahead and do the distributive property, a lot of times what you're going to have to do next is you're going to have to what's called combine like terms, okay? Now, we remember what terms are. Terms are just the chunks, okay? But we got to really talk about what's a like term and what's not a like term, okay? So let's just try a couple examples and see if we can talk about that a little bit more, okay? So here we go. We got negative 7x minus x plus 6 minus 3, okay? If someone's asking you to simplify this, first of all, you want to ask yourself, are there any parentheses to get rid of using distributive property or what have you? There is not. Therefore, we're on to the next step, which is combining like terms, okay? Now, the like terms here that we're looking at are these two, okay? So we got negative 7x and then we got a negative x, okay? These are like terms because they both share an x, okay? They don't look like each other. However, they share the same, let's say, variable, okay? They have different coefficients. For example, there's a negative 7 here versus a negative, and if there's nothing in front of the x, we can always call that a 1. So there's a negative 7 as a coefficient and a negative 1. The way we combine like terms, I like to think of this as just the number of copies I have. So I have negative 7 copies of x, and I also have negative 1 copies of x. Altogether, when I put that together, I have negative 8 copies of x, because negative 7 minus 1 is negative 8, okay? So I have negative 8 copies of x. So that's how I combine like terms. Now these other ones, these are just what we like to call numbers. Numbers all by themselves, because they have no variables, they have nothing attached, they combine as well, just like you would normally do in an addition or a subtraction problem. So we got positive 6 minus 3, which is just going to give us a positive 3, okay? And that would be a simplified version of the algebraic expression we had before. All right, let's just try one more and then we'll end on that. All right, so here we go. The last one we are going to do involves a little exponents. It's not that scary, I promise. Negative 5x squared plus x squared, and then we got plus 3x, okay? Now, just because it has a variable doesn't mean that it always will combine with other things with variables. You have to make sure that each term has the same variable before you combine. So if you look at that first term, it has a negative 5, which we're not really concerned about. We're more concerned about the variable x squared. I want you to look at this expression. Not all of them have x squared. Some of them actually don't. So if you look at the second one, that has an x squared. So we're actually going to use that to combine with a negative 5x squared. But if you look at this one on the right, it doesn't look like it. Sure, it's similar because it does have a variable, but it does not have an x squared. So we cannot combine this one with the ones before it, okay? So let's combine these ones. Again, the term itself, the variables don't change. It's just the coefficients that we're adding, okay? The variable just kind of stays along for the ride. So negative 5 x squared plus x squared. If we don't know what the coefficient is, again, we can always draw ones where we don't see coefficients, because that would be a safe thing to do. Negative 5x plus 1x squared is just going to be a negative 4x squared. And then we're just going to add that 3x to it, okay? Again, we're not trying to solve for anything. This is just an expression. This is just simplifying. but all we are doing is just combining like terms and using the distributive property, okay? You are pretty much done simplifying when there are no more parentheses and you have combined all the like terms. We are going to add a couple more steps to this process later on in the class, but for now, that's all you need to remember. Did you, one, distribute? Are there no more parentheses? And number two, did you combine like terms? And after you've done that, you're pretty, I hope that you're pretty confident that you have simplified successfully that expression that you were trying to simplify. All right, so that's it for today. See you again. See ya.